Specific heat capacity. Heat capacity of an object is the quantity of heat required to change its temperature by 1 degree Celsius. So, what is heat capacity? So, if we have an object and we want to change the temperature by 1 degree Celsius, that is, we are going to increase or decrease by 1 degree Celsius, then what is the quantity of heat? So, that is called as heat capacity. So, heat capacity equals to Q by delta T. So, this is the expression which you have to remember, that is heat capacity equals to Q by delta T, and from this Q equals to heat capacity into delta T. So that is what I have shown. Q is equals to heat capacity C into delta T. Now, what is specific heat capacity? It is the heat required to raise the temperature by 1 degree Celsius of the 1 kilogram material. So here it is, we are considering for unit mass there is 1 kilogram. So that is what a specific heat capacity is. So if suppose mass is m and heat given is Q and rise in temperature is delta T, then let us see how we are getting this expression. So this is simple to understand. For m kilogram, we give heat energy Q amount. So for m kilogram, we give Q joules to raise the temperature by delta T. Okay. For 1 kilogram, what will be the heat given? That is Q by m. Okay. For m, it is Q. What about for 1? It is Q by m. So that is how you have to understand. So for delta T temperature rise, heat given is Q by m. What will be for 1 degree Celsius rise in temperature? It is Q by m delta T. So this is nothing but the specific heat capacity. So Q by m delta T equals to C. So from this we can write Q equals to mc delta T. So where C is small c, this is molar specific heat capacity. What is molar specific heat capacity? This is the heat required to raise the temperature of 1 mole of material by 1 degree Celsius. So that is molar specific heat capacity. And mercury has the lowest specific heat, and that is used as thermometer. So yes, it is having low, it is not lowest, it is having low specific heat. So that is the reason we are using it in thermometer. Okay. So now we will learn calorimetry. It is easy topic. So yes, generally it says during exchange of heat, heat given by the hot body is equals to the heat received by the cold body. Now let us see how we are getting the equation. So here we have a calorimeter, and we have a copper part which is a thermally insulated box, which is in the thermally insulated box, and here we have water, and the water is in the calorimeter. So now we are going to drop a hot body of temperature TH. Okay, we are going to drop a hot body that is having the temperature TH into that water. Okay, so what will be happening? That hot body will lose the temperature, that is will lose the heat, and this water and calorimeter both, water and calorimeter both will take the heat. So the heat is lost by the hot body and the heat is gained by the water in the calorimeter. Now what is the heat given by the calorimeter? So the then general equation is mc delta T. So here we have to be very careful with the masses and the specific heat capacities. Okay. So here we have to take the mass of that hot body, that is mass of that solid, and specific heat of that solid into what is. So delta T here is TH minus TF. So before that I will say one thing. So initially we are dropping a ball or a hot object which is at temperature TH, and the initial temperature of water and the calorimeter, because they are in contact with each other, so they may have same temperature, that is TW. Okay, so the initial temperature of the solid is TH and initial temperature of the water and calorimeter is TW. On dropping the ball, their temperatures is going to get changed, because this loses heat and these two will gain the heat. So the final temperature will be something different, that is TF. Okay, that is T final. So this is all about the things, variables we have to be aware of. Now let us see uh, what is delta T here. So here it is TH minus TF. So you can see TH is the initial temperature of the hot body, and final temperature it has attained. So here you are you can just remember the higher temperature minus lower temperature, because it is easy to remember. So if it is initially the ball is at 45 degrees Celsius and the final temperature is becoming 10 degrees Celsius, then it is that is higher temperature minus lower temperature, TH minus TF. So please remember it like that. And what is heat received? What is the heat received? Who are all receiving the heat? Both water and the calorimeter. So we have to consider the heat energy for both of them. MC delta T of water plus MC delta T of calorimeter. So here you have to take the water, mass of the water, and C is the specific heat capacity of water, and that is 4180 if we are considering in kilograms. You can use 4180 and delta T. So please remember this value, delta T of water. So here again, as I told you, higher temperature minus lower temperature. So generally delta T means T final minus T initial, but please here you can remember for a easy remembering, you can remember it is higher temperature minus lower temperature. So we know the water and calorimeter has gained the temperature. So if initially they were at 5 degrees Celsius and they are gaining 5 more degrees Celsius and they are becoming 10 degrees Celsius, then which is the higher temperature? 10 degrees Celsius is the higher temperature. That is, the final temperature is the higher temperature and the initial temperature was only 5. So here you have to take T final minus TW. And similarly for calorimeter, you can consider mass of calorimeter into C is the specific heat capacity of the calorimeter that may be given in the question, and T final minus TW, T water. So this is the heat received, and what is it says this and this will be saved. So in latent heat, the heat required to convert one state of matter to the other state without change of temperature. So that is latent heat. So let us take an example. So if we are if we are going to convert an ice at 0 degrees Celsius into the water at 0 degrees Celsius, then for that there will be some amount of heat required, and that heat is called as latent heat. So please you have to note one more thing here, there is no change of temperature, there is only change of state. Q equals to M into L. Okay, so here L is the latent heat and M is the mass. And now we have to know one more thing. We have already seen Q equals to MC delta T, and now we are seeing Q equals to ML. So we should know at which point we have to use which formula. Q equals to MC delta T. So that formula is only for the temperature change, okay, and there is no change of state in that formula. So please note that Q equals to MC delta T. So that is this formula, Q equals to MC delta T. So this, if we are considering a amount of water, if the water, if the temperature of water is changing from 0 degree Celsius to 10 degree Celsius, and that is in water state only, then we can use this formula Q equals to MC delta T, because here there is no change of state but there is a change in temperature. And when we will be using Q equals to ML, so this we are going to use when there is there is the state change but there is no temperature change. Okay, please note the difference between these two formula. Okay, let us see the thermal expansion in case of liquids. So here we are considering a flask in which the liquid level was initially filled up to the level A. Okay, so now we are going to heat the flask. On heating, immediately the volume of the flask will also undergo expansion, thermal expansion. So because of the increase in volume of that flask, immediately the level will fall from A to B, because previously the flask is in this size. So if it is expanded, it may have some small increase in size. So if the small increase in size, then the liquid level, the same amount of liquid here will occupy only lesser volume, right? So we have to understand that. So because of that expansion of the flask, volumetric expansion of the flask, the liquid level is immediately falling from A to B. But on further increasing the temperature, the liquid also expands. So the liquid is going to expand from B to C. Okay, so initially it was at A, and because of expansion of the solid, that is the flask, it has fallen to B. Now it is going to increase its volume from B to C. Okay, finally it is rising from B to C. But for us, for the person who observes it, how does he feel? It will be seen in such a case that the water has risen from A to C. So that is what is seen generally, right? Because it has fallen and then it has risen. So, but we see, we can finally say it is increased from A to C. That is what will be your observation. So now let us see this. So we can say BC is equals to AC plus AB. Yes, from this we can say that. And what is BC? So B to C is actually the real expansion of liquid. So that is called as V real, delta V real. Okay, now that is expansion, real expansion of liquid. What is AC? From A to C, it is what we are observing. So it is observed that the liquid is rising from A to C, level A to level C. So that can be taken as apparent expansion of the liquid. And what about AB? And that is the reason for falling in the level of liquid level. That was because of volumetric expansion of vessel. So that is for vessel. Okay, that is volumetric expansion of vessel. Now, we have already seen that delta V equals to it is V gamma delta T. So here we are all discussing about the volumetric expansion. So we are using the term gamma. So for real expansion, so general equation you remember, remember it is L delta L is equals to L alpha delta T. Similarly, delta V equals to V gamma delta T. From that we can write gamma equals to delta V by V delta T. So what is gamma R? That is coefficient of real expansion, and that is equals to delta V real by V into delta T. Similarly, coefficient of apparent expansion is gamma A, that is equals to delta VA by V delta T. So similarly, we are writing for volumetric expansion of vessel. So from this we can write real expansion is equals to apparent expansion plus volumetric expansion of liquid. So that is gamma real V delta T equals to gamma A V delta T plus gamma G V delta T. So just now we are from this we are writing, okay, delta VA equals to gamma A V delta T, like that we are writing. V delta T goes everywhere, so it is gamma R equals to, that is real equals to gamma A plus gamma G. So this is what is the expression we are getting. Water shows anomalous behavior. So if we all might have known this earlier. So on heating, generally the volume increases, but if we take water, on heating from 0 degrees Celsius to 4 degrees Celsius, instead of expansion, the water shows contraction. So that is what is anomalous expansion or anomalous behavior of water. So from 0 to 4 degrees Celsius, on heating from 0 to 4 degrees Celsius, instead of expansion, the water is going to show a contraction. So yes, instead of expansion, it will show contraction. So what can we say? After that, on increasing the temperature from 4 degrees Celsius to some degrees Celsius, like 15, 20, again the volume is going to increase. Okay, so we can say from this the volume of water is minimum at 4 degrees Celsius. Okay, so please note that. And similarly, we can talk about density. We know density is equals to mass by volume, so it is inversely proportional to volume. So yes, so if the volume of water is minimum at 4 degrees Celsius, then we can say the density of water will be maximum at 4 degrees Celsius, and the graph is just opposite to that of volume. At first, from 0 to 4 degrees Celsius, it increases, the density of water increases, then it is decreasing. Okay, yes, and we have seen this type of equations already. So here it is, V dash is equals to V into 1 plus gamma delta T, and if it is density, that is, this is V is initial volume, and gamma is the coefficient of volumetric expansion, delta T is the change in temperature, and V dash is the new volume. So V dash is equals to V plus V alpha, V gamma delta T. So similarly, this is the equation for volume. How we write for density? New density equals to density minus density into gamma delta T. So here only we are using minus symbol. So please have a note on it. So remaining places we have used only plus. Yes, please have a note.